Everybody. Thank you for coming tonight. Thank you to Allison here from UC for the Environmental Law Society over there joining us with this event. Our first speaker tonight is going to be Mr. Aaron Patrick. He's an associate director with the Kentucky Department of Energy. To his left is Mr. Lloyd Kress. He is general counsel for the Kentucky Coal Association. And at the end of the table is Bill Bissett. He's the president of the Kentucky Coal Association. We are awaiting Miss Terry Blanton. She is a fellow with the Kentuckians for the Commonwealth, and she should be here any minute. So without further ado, we'll let them get started.
Okay, so good evening, everyone. My name is Aaron, and I think I have the coolest job in Frankfurt. My teammate and I, Adam, who's over there in the front row, two of us manage all of the state's energy and environmental data, and we do a lot of forecasting of that data forwards in time. So I work for all of you. I work for Bill, I work for Terry, I work for everybody, and we answer everybody's data questions. So anything you want to know about coal, you're welcome to shoot us an email, and we'll try to answer your questions as best we can. I'm going to walk through a little bit of the trends in Kentucky coal production. So how many of you guys have heard that Kentucky coal production is declining? Okay, so everybody's aware of that. Well, there's people that mine that coal, so employment is declining as well. Our electricity portfolio today, as I hope everyone knows, is coal-fired. We're at 92.7%. Talk about that. I'm going to look at the future, look at what new environmental regulations, state and federal, are driving us towards, which is natural gas. And then we're going to talk about what it matters to the Kentucky economy. So this is a quick map of where coal production takes place across the United States. This runs all the way to the end of 2013. As you can see, Kentucky's coal production is divided in an east and west side of the state. The gray dots here represent the underground mines, and the green dots represent surface mines. And so this is animated in time from 2000 all the way to 2013. And in western Kentucky, we've got the Illinois Basin. The Illinois Basin is shared with Indiana and Illinois, obviously. And in eastern Kentucky, we have our central Appalachian Basin, which is shared with Virginia, West Virginia, and Ohio. Eastern Kentucky coal has got lower sulfur content, higher heat content, so it's better coal. It's also more expensive. Western Kentucky coal, a little bit higher sulfur, lower heat content, but has the advantage of being a lot cheaper. So that same data that you just saw animated spatially, I'm going to put onto a time series here, and I love maps and graphs, and so forgive me if I get too excited about this. But this is a time series of Kentucky coal production, and it is declining. The black line is Kentucky's total. The blue line is for eastern Kentucky coal production, so we use blue for the cats, and western Kentucky coal production there in red. Western Kentucky coal production is stable and rising. So if you saw from the last map, most of western Kentucky coal production is underground. And eastern Kentucky coal production is about a 50-50 split between surface and underground. And I've been with the cabinet for 4 years, and so we've seen this change over there on the end, which is the shift from eastern Kentucky being our dominant coal producer to western Kentucky being the dominant coal producer in this past year. So this is the same data. Zoom out. 1960 to present. We get a little bit different idea here. So if we change the time period, you get kind of a different story. So this graphic shows you that, again, that eastern Kentucky coal production is our dominant, has always been our dominant coal producing field, peaking in 1990, and you can kind of get a better idea of western Kentucky coal production from thereafter. Zoom out again. Back to 1860. Kentucky started mining coal in 1790, which was before Kentucky was a state, so it was still Virginia. But we've only started this graphic in 1860 because there really wasn't a lot going on before that. Coal production kicks off in 1880. You can see the two world wars really clearly there. You see the First World War, see production ramping up to meet the industrial needs of the United States, and in the Second World War. You can then see the coal production peaking in 1990 and declining thereafter. So the declines that we've experienced, I'm going to use the mouse, I don't know if you guys can see it. Okay, good, you can. So the declines that we saw in the first graphics really are part of a larger decline from 1990. So when my phone rings and people are asking me questions, typically they're less concerned with the actual coal production or all of the dollars that are coming from the coal production. Obviously, that's a major source of revenue in terms of income taxes and coal severance taxes. It's a huge source of revenue for the state as a whole. But in those counties that we were talking about, it's a really significant driver. In some of the counties, you're looking at 30, 40% of the total income coming into a county is coming from coal production, so a really big driver. But when my phone rings, it's really about this. It's about the job losses that we've been experiencing since 2011. So since 2011, we've lost 7,000 coal mining jobs in eastern Kentucky, which is a really, really big problem in those counties where there weren't a lot of other employment opportunities. But those declines, put in a larger historical context, are smaller on this trend there. We had up to 80,000 coal miners in the 1940s, and it's declined through automation, mechanization of the mining processes. But zooming into recent history, most of our adult lives, I think everyone in this room, most of our adult lives have hovered right around 15,000 to 20,000 coal miners. So there's ups and downs, but we've had about 15 to 20,000 coal miners until recently. In 2011, the past 24 months, we've lost 7,000 coal miners. So it's a very quick and precipitous decline. So looking at the change in coal mine employment nationally, here Adam and I have colored the counties by whether they've grown in employment or reduced in employment. So far, we've just been looking at the Kentucky coal production and employment trends, but the layoffs nationally in coal mines are occurring in eastern Kentucky, right? So you can see that red-hot area in eastern Kentucky, a little bit of spillover into West Virginia, but Kentucky is really bearing the brunt of reductions in coal production. So we have all this data by mine. We have lists of names and phone numbers of coal miners, so these data are very, very real and personal to us. The red dots here indicate a coal mine that's closed. It's no longer in business. A green dot is a coal mine that has grown, has added workers, and then an orange or yellow dot is an orange dot is a mine that has reduced its staff in this past 2-year period. So these layoffs are very, very real, and they are concentrated here in Kentucky. Looking at the change in coal mine employment nationally, there have been job losses all across the United States, but they have really been concentrated in Kentucky. We've borne the brunt of that, as I said. There have been some losses in West Virginia as well, but Kentucky accounts for half of all of the job losses in our coal mining employment. So where does all this coal go? Okay, well, another animated map here. From 1990 to 2013, what we did is we took all of the Kentucky coal shipments inside the United States. We're tracking about 90% of all the coal that's produced. We can tell you where it goes. The blue dot represents an eastern Kentucky coal shipment, annualized, and the red dot represents a western Kentucky coal shipment. What you can tell is 90% of the coal that we mine here in Kentucky goes to keeping the lights on here in the United States. 2013, you'll note that the market is reduced in space and in size from West Virginia all the way down to Florida. That's where Kentucky coal is being primarily used. The western Kentucky coal is biggest consumer is actually right here in Kentucky. So we're here to talk about the future. So looking at those same power plants that buy our coal, here the gray dot is just one that's up and running. The red dot is one that has announced that it is closing between 2013 and 2018. So there's going to be, we've had serious losses in coal production and serious losses in coal mining employment, but in the near future there's going to be continued losses as these coal-fired power plants are retired. I should note that most of them are being retired due to agreements with the Environmental Protection Agency. We've looked at the rest of the coal-fired power plants, those gray dots. Here they're colored green to orange. The green dots are ones that are clean and new, and we deem will probably keep running for a long, long time into the future. The orange dots are dots that haven't announced that they're closing, but they're older and they're not quite as clean, and so we think they're vulnerable to closure as well. Looking at all the coal-fired power plants in the United States, so 92% of all U.S. coal goes to electricity generation right here in the United States. Those coal-fired power plants are distributed all across the country. Of the 345 gigawatts of coal-fired power plants that there were in 2012, we've got 33 gigawatts that are scheduled for retirement between 2013 and 2018 that are going to be shutting offline. Again, looking at the probability of more retirements beyond that, the green dots represent a coal-fired power plant that we deem probably is going to be online into the future, into the 2020s. A good 240 gigawatts of capacity that is stable for foreseeable future. But there's those 33 gigawatts going offline and an additional 50 gigawatts that are vulnerable to closure in the near future. So all of that is going to have implications. So the question of this symposium obviously is the future of coal. And so this is how we thought best to try to answer that. So I'll try to speed up. United States electricity generation, pretty balanced actually in terms of our fuel sources, but we've always been primarily a coal-fired electricity portfolio nationally, 38%, 30% gas and 20% nuclear, about 10% renewables. I'll use the cursor here. This is wind. This wind is very new, but the biggest growing pie is natural gas. Kentucky, not so much. We are 92.7% coal in 2013, and we have a little bit of natural gas and petroleum that we use for peaking, and we have hydro dams that were built by the Army Corps of Engineers like in the 20s and 30s. Looking at that data over time, I like lots of different kinds of graphs here. You can see the United States portfolio has been predominantly coal, but is becoming increasingly diversified in the 2012 timeframe. You've got increasing natural gas, and that is eating into coal's share of total generation. And for the green there at the top are renewable energy resources. That's largely wind, actually. That's the wind that's increasing so rapidly. The other thing that's eating into coal, or the coal-fired generation here in this graphic, and you may not notice it right off the bat, is declining growth. So electricity demand growth was growing rapidly in the 60s and 70s as we industrialized as a nation, and you can see the growth there through 2000, but in around 2006, we see slowing growth, and of course the recession and moderate growth thereafter. So we have slower growth, so you need less electricity to be generated. Kentucky, we, again, 92.7% coal, and we always have been. Looking at that data monthly, which is just for interesting in terms of statistics, does anybody know what those mountain peaks are at the top? Want to throw out a guess? Winter and summer. You're both right. Yeah, winter and summer. So it gets really hot. We turn on our air conditioners. It gets really cold. We turn on our heaters. And that's really driving those peaks. And you see the very, very top of those mountains there, those little, I like to call them the snow peaks. Those are natural gas units being used only when we have to. Well, what about the future? Well, this is what we spend a lot of time doing. I'm not going to get into the regulations. This presentation's online, and I'm sure everyone else will probably get into the regulations. But there's a lot of new environmental regulations that are changing the dynamics of how we're going to produce electricity in this country. One of the biggest ones and the most challenging hurdles for coal, since this is a question you're asking, is what's the future of coal? One of the most challenging is a greenhouse gas emissions reduction or carbon reduction. Well, coal is carbon. That's why you want coal, because it has carbon content in it. And so that it's going to be very difficult for coal-fired electricity generation. So moving forward, we have a confluence of factors at play here, and I'm going to try to explain this graphic. This is that same graph you just saw running all the way up to 2050. Moving forward in time, our models that we've built estimate that Kentucky will move quickly over to natural gas away from coal. Let me explain what's going on. First, you have coal-fired power plant retirements. We've shown you those on a map. There's a lot of those. And you can really see the natural gas coming online in 2016. Those have been announced. Those are already, some of them are under construction. Cane Run, Paradise. There's some of these are being litigated in court, but there's plans in play. Later on, as coal-fired power plants are retired because of their age, and the new laws in play will not allow us to build new coal-fired power plants, we really have no choice, other than natural gas. And so Kentucky, per Kentucky state law, we're required to choose the least cost option that complies with federal law, and that's gas. There's really no other option for Kentucky given our state laws and our federal laws. So jumping at that pie chart, that 92.7, playing it forwards in time, we quickly become primarily natural gas. What does that mean for the future of Kentucky's own coal consumption? So please don't mistake this for coal production. We may still be producing coal, but if our coal-fired power plants go offline, their own consumption is going to decline. That should be rather obvious. Our greenhouse gas emissions don't actually go down that much. There's a lot of change we're basically going to get rid of in these simulations. You're getting rid of all of our electricity generating power plants and replacing them with new ones, but our greenhouse gas emissions really aren't that improved. And that's because we're moving from one fossil fuel over to another fossil fuel. We're moving from coal to natural gas. Okay, and before I run out of time, I'm going to tell you the so what. Okay, so we talked about the coal mining jobs. We talked about all the money that is generated from coal. Yes, that's definitely true, but that's the small part of it. That's the really small part of it. I'm going to jump to the big part of it. This is a graph of natural gas prices and coal prices, and obviously it shows you natural gas prices is more expensive in terms of the heat content that you're paying for it. But the other thing that you look at, other than that natural gas is higher now and historically, is that natural gas prices are volatile. In some years, they've risen by over 100%, and they fall back off. So they're extremely difficult to predict. This graphic is one the Governor's Secretary, Dr. Peters, had me make, which is to show the federal government's efforts to predict natural gas prices historically. The black line are natural gas prices that we actually observed, and each colored line is the US government's best effort at predicting those natural gas prices forwards. So if you look at 1980 there, I think you may not be able to see too well, but if you look at 1980, you can see gas prices started to fall back down from a pretty high point. And the federal government every year predicted consecutively that natural gas prices were going to rise. If you move forwards in time to about 1998, and then you see natural gas prices start to rise. And the federal government every year repeatedly predicted that natural gas prices were going to fall and be stable forever. So who cares? I'm not here to beat up on the US Department of Energy. The point of this graphic is to say we don't know what natural gas prices are going to be in the future, and so before we abandon one electricity generating technology, a fossil fuel, for another electricity generating technology, before we abandon a resource that we actually have here in Kentucky and we start importing natural gas from out of state, we need to stop and ask some serious questions. They're predicting that natural gas prices from now until 2040 will never again be as high as they were in 2009. This may be true. Fracking has changed everything. All kinds of things have changed everything. But we just want to proceed with caution. Why? This is a graph of electricity prices, including every state and every year across the United States. Gray dots are all the other states. Black dots are Kentucky. And the red line is the US average. Well, Kentucky, since the beginning of time, has had one of the lowest electricity prices in the country. And there's no doubt that's because of coal. So coal, no, it's not low carbon, but yes, it's cheap. And from 1990 forwards, or 2000 forwards, actually, we're in the bottom 5. And in 2013, Kentucky had the second lowest electricity price in the United States. So what? That's not about you and me and our electricity bills. It's actually about our economy. This is a graph, exact same graph, except it looks like I flipped it upside down. I didn't. This graph is of electricity intensity. That's the amount of electricity you consume per dollar of GDP that you create. Kentucky is the single most electricity-intensive economy in the United States. We consume more electricity than anybody else in the United States per dollar. Towards the bottom of that list, some of the bottom 2 gray dots, you've got New York and California. So Wall Street, I can make a lot of money, and I don't need a lot of electricity. Well, that's because we have a different economy. Here in Kentucky, we make things. We make aluminum, we make steel, we make iron, we make glass. The glass that's on your iPhone and your iPad, that came from Kentucky. And we're proud of that. We're very proud that we make things. So your Toyota that you're driving somewhere else, we made it here, and we're getting dinged for the greenhouse gas emissions, and you get to drive it there. And so some big questions that we have to ask. The United States electricity portfolio, pretty balanced into thirds, with industrial, commercial, and residential. Kentucky, not so much. We are half industrial. We are half manufacturing. What does that mean? So when you talk about moving from one energy source to another, be it from coal to gas or you want to do solar panels, half of the electricity that you're talking about is going to manufacturing, to industrial consumers. The United States has always been pretty well balanced: residential, commercial, industrial. Not so much. Kentucky, we have always been industrial. Right in the beginning, even before the data came online, all of the electricity went to manufacturing. And initially, when the data sets started coming online in 1960, the overwhelming majority of our electricity went to manufacturing. So what? And Dr. Peters wanted this animated, so this graph gets animated. You hear a lot of talk about green jobs, solar panels and windmills, and I just talked about the coal miners. All of those jobs, as much as we want those jobs, we want green jobs, we want coal mining jobs, only add up to 15,000 jobs. 15,000 jobs to produce electricity here in Kentucky. And I'm not talking about what we could do to produce electricity for other states, sending coal out of states. I'm talking about just what we need, how many jobs we need for our electricity portfolio. Well, there's 225,000 people employed in manufacturing. Obviously, the size of the ball represents how many people are employed in that industry. And there's 2.1 million other people employed in Kentucky that depend upon electricity. There's so much talk about these 15,000 jobs or the 5,000 jobs, and we lose sight of the point of those jobs. The point of those jobs is to produce electricity for a larger economy. I'm almost done. Same thing, size of the ball represents the size of the industry. The height of the ball now represents their sensitivity to changes in electricity prices. And because we don't have much time, I took out all the really cool Greek math slides that explain how these are calculated. They're on our website, and I encourage you to go download it. But just to tell you the results of our analysis, again, height of the ball is sensitivity to changes in electricity prices. We've found that a 10% increase in electricity prices will reduce employment in our manufacturing sector by 3.3%. Our retail trade, our hospitality, they're about half as sensitive, not quite as sensitive as our manufacturers. With a 10% increase would reduce employment by about 1.5%. Government employment, healthcare employment, over there on the right-hand side, they're at the zero line. You change their electricity price, they're not going to do anything with employment. Whatever the bill here is in Northern Kentucky's campus, they're not going to turn the lights out in here because of it. They're not responsive to changes in price. Well, this should make intuitive sense, and let me explain why. So this is a table, there's a complete list of the Kentucky industries in the paper on our website, but this is the table of the top and the bottom of that complete list. Our most electricity-intensive sector is aluminum smelting. We've got 3,500 people that work in melting aluminum here in Kentucky. So what? Well, they need 4.4 kilowatt hours of electricity to make $1 of aluminum. So what? Well, that's 25 cents. So 25 cents of their final product is electricity. So if we change their price, we're actually seeing that we published this paper a couple years ago, but we've seen this happen in the real world. As the price changes, they say, well, we're leaving. If you're going to change the price, we're leaving. Iron and steel mills, not quite as sensitive, but they need 10 cents of electricity to make $1. Basic chemicals, glass manufacturing, 3 cents. And all the way down there at the bottom, the jobs that we're so proud of as Kentuckians are motor vehicle parts and motor vehicle assembly, not really sensitive at all. But what do you notice about this table? Cars need car parts. Car parts need iron, steel, aluminum, and glass. And so our entire economy is this interwoven web of vulnerability to changes in electricity prices. So the only point of this is just to say, careful, Kentucky. Think about where you're headed. Think about where you're going. Here's just a basic simulation of future employment in these electricity-intensive sectors. The black line is what if you hadn't. The red line is what if you had changed electricity prices by 25%. We estimate 30,000 jobs would be lost in Kentucky, or would be failed to be created because of a higher electricity price. So that doesn't mean that other opportunities aren't going to come. It would be great if Google and Microsoft were so interested in this informatics building that they relocated to northern Kentucky. That would be great. We'd love to be the hub of that. But right now, we're the hub of other industries that are very, very vulnerable. And I think I'm done.
Thank you, Aaron. That was an awesome presentation. Next, we're going to hear from Miss Terry Blanton. She is a fellow with the Kentuckians for the Commonwealth. Oh, you're fine. Take your time.
No. So can I just use this microphone instead of this one? Yeah? Okay, I don't have a big shiny presentation, and I'm very sorry that I'm late, but I depended on technology, which took me to a field on top of a hill and said, "You are here." And I looked around and I said, "I don't think I'm here." So I got a little bit late. And I was a little, first let me explain myself. My name is Terry Blanton. I have what some people consider an activist against coal mining most of my life, but mostly what I've asked for is clean air and clean water. I grew up in Harlan County. A processing plant moved right into my community. The creek that I grew up on now runs toxic with acid mine drainage from one side and toxic mine drainage from the other. And just a short little story, I've been having them check on this stream since the early 80s when the mining was happening in my community. And of course, the company that did it filed bankruptcy, closed down this operation and opened up under another name. So the cleanup was left for the taxpayers of Kentucky, which is not unusual in the coal industry. This gentleman here asked me, I think Zachary, asked me to put together a presentation. I worked on it all week and then I sort of lost it, so I don't really have a presentation for sure, but I would like to ask Aron one question. It says we cannot build coal-fired power plants anymore, and I don't think that's a part of it. I thought that we had to have coal-fired power plants that met certain air regulations. Correct.
We have to have less than 1,100 pounds of carbon dioxide per megawatt hour, but that is expensive. The Kentucky law requires the least cost technology, so that would fit it with more expensive areas.
Yes, but how many millions and millions of dollars have we funneled into the so-called carbon capture and sequestration to make our coal clean, just in the state of Kentucky alone? I know every election, that ugly future gen rears its head up there in Indiana or Illinois about, putting money into future gen to study carbon sequestration, capture and sequestration. So I don't think it's really fair to say that we cannot build coal-fired power plants in the United States anymore. We can build them if we build them to standard, right?
So first of all, it's never been demonstrated on the size. The technology has never been demonstrated first. Second, the costs are 3 times higher than natural gas. So it's illegal in a Kentucky revised statute that requires the least cost generation.
Okay. Well, if we ever change that law about less expensive, yeah. I'm still a little shook up. So I have a presentation here, and it's not really about, it's about how I feel about coal and how I feel about what's went on in my state for the past 100 years. And it's not about energy, it's about power. We live in interesting times. It's not an exaggeration to say that our nation, not to mention our planet, and international community is on the brink of a dramatic economic, environmental, and energy crisis. From fuel to food, housing to health care, drinkable water to breathable air. We are facing serious, serious problems. To make matters more frightening, global climate change is here and it threatens us all. It is clear that if we don't change course, there won't be winners and losers in the new global climate, as some have suggested, only losers and bigger losers. The impact will be universal, severe, and for all practical purposes, irreversible. While the scope of the problem is global, few places in the developed world are more vulnerable to these looming crises than Kentucky. We have been suffering the effects of the fossil fuel economy and experiencing the first signs of global climate change for over a century. If anyone's seen the newspaper the last couple of days,